So how do we go about doing that? Well, once again, we could do a couple of different things. We could go through the parameterization like we mentioned before, and we could do the old switcheroo on the t-hat because it's two-dimensional motion. But I want to go back to Calc 1 and think about Calc 1 and how this all ties together. Let's just take the derivative here, y equals, or y prime is 2x, and substitute x equals 2. I get 4. This is the slope of the tangent line at 2, 4. So we can get a tangent vector out of this because remember slope, the slope is the rise over the run. Right? That's the change in y over the change in x. So I can decouple this slope and think of 4 as being 4 over 1, and that corresponds to a vector, I'm just going to call it v for now, of rise over run, so 1 comma 4. If I want to get the direction of this vector, I could certainly find its magnitude. And so this gives me a tangent vector. I'm going to call it v hat. I take this divided by that. Which, once again, I can rationalize here. Like that. Now I can do the old switcheroo on this one, because all I need is a normal vector at the point 2 comma 4. So remember how the old switcheroo works. You switch the components and make one of them negative. So I switch the order and make one of them negative, or I switch the order to make the other one negative. And then I pick whichever one of these lies on the concave side of the curve. So I go back to my little sketch here, like so. There's the point 2 comma 4, and the question is which of these is going to point in that direction. Well, if I'm pointing in that direction, I need to have a negative x component and a positive y component. That's this one right here. That's the guy that I need. So this tells me the direction to go. I need to start at the point 2 comma 4 and head off in that direction. So the very last piece of this is then to use the direction with the distance I need to go to get to the actual center of curvature. Okay, so here's the n hat. That's the direction we need to go. Here's the radius of curvature. That's how far we have to go. So I can put this together and give me a function. I'll call it, or it's not a function, a vector w. Go ahead and call it w. R sub k times n hat. And what w is going to be is, let's draw the schematic here before I get too carried away, to remind us of the plan. Whoops. Well, you know what I mean there. So here's the point 2 comma 4, and the center of curvature is out here somewhere. So this is going to be the vector w. It's going to be the correct multiple of n hat. That'll get me from 2, 4 to the center of curvature. So that's what w is. Let's go ahead and compute that. It's 17 radical 17 over 2 times negative 4 radical 17 over 17 radical 17 over 17. So let's simplify that. We'll take this times each of the components and look what's going to happen. The 17s are going to cancel out. I've got a 17 times radical 17, which is 17. I've got 2 going into that, negative 2 times. So I get negative 2 times 17 is negative 34. And then over here I get the same thing happening. 17's cancel, 17 in the numerator over 2. So that's the vector negative 34 17/2, which means that we need to start at the point 2 comma 4, move over to the left 34 units, and then up 17/2. So the center of curvature you start at 2 and go left 34, subtract 34, and start at 4 and add 17/2. So I get negative 32. Get a common denominator here. I get 8/2. 8 and 7 is 8 and 17 is 25 halves. So that's the center of curvature. Is that right there? All right. So finally, we've got our radius and we've got our center. It's time to write our circle. So the circle of curvature. X minus the x component, quantity squared. X minus negative 32 is x plus 32, quantity squared. Plus y minus the y component, quantity squared, equals, I got to square this. So what do I get when I square this? I get 17 times 17, radical 17 times 17, 2 times 2. So I'm going to get 17 cubed over 4. And that's our circle of curvature. Okay, so to show you or convince you that this is the right answer, I've gone to Maple. I've called the plots package. I'm plotting the circle and the parabola near the point 2 comma 4. So we can see the red line here is the parabola, and we can see the blue line is the circle of curvature. And you'll notice something interesting about this circle of curvature. It actually crosses through. So not only is it tangent at the point 2, 4, but it actually crosses through. And we can zoom in here to actually see what's going on. Near the point 2, 4. And we can see as we zoom in closer and closer, the circle and the parabola become indistinguishable. Okay? And so that'll do it then for checkpoint 4.